Welcome to the Data Hall YouTube channel. In today's video, we are going to discuss an important topic, that is how do we perform dummy variable regression in Strata. And this tutorial is not going to be a small tutorial covering a specific topic, but we are going to make a holistic tutorial that would surround, we would try to surround every topic, discuss every topic related to dummy variable regressions in Strata. So we'll discuss how do we perform regression when we have a single categorical variable in, and we would also discuss margins and margin plots. And margin plots are a great way of communicating to a non-statistician person or even to ourselves that what the result depicts. Then we would discuss multiple categorical variables in regression. If we have a single categorical and a continuous variable, if we have interaction between categorical and continuous, between two categorical and between two continuous variable, and we'd also discuss three-way interaction. So as you can imagine, it is going to be a holistic tutorial regarding many topics of dummy variable regression or categorical variable or interactions. So let's start with the first one, which is a single categorical variable in regression. So let's load our dataset, and I have made a dataset for the purpose of this video. And what do we have in this data is we have an ID of an individual, their gender, their education. We have 4 different categories of education: primary, secondary, bachelor's, and we have master's. Then we have their salary, which is a numerical variable, their age, and we have conducted certain tests from these individuals. We have their marks. Do remember that it is a hypothetical data, so the result do not depict the real life scenarios. Okay, so how do we generate the dummy variables? So there are multiple ways, but I would just go through the manual way, and then I would quickly give you an easy way of generating these dummy variables. By going through the manual way, you would know that the way that we use the shortcut way is correct, and you would have a more in-depth idea of how this would work. So let's start with generating a dummy variable. We use this tabulate command, which tabulate is the result, but there is an option of generate. And what this would do is it would take this gender variable, it would generate different variables based on their categories. So if there are 2 categories, it would generate two variables by the name of gender 1, gender 2. If there are 4 categories, then it would generate 4 different variables. So if I execute this, you can see that we have gender 1 and gender 2. But does gender 1 represent male or female? We can see that gender 1 contains value of 1 when there is female. So that means that gender 1 is related to female and gender 2 is related to males, because it contains 0 when there is a female in our data and 1 when there is a male in our data. So it would be rather a better way to rename these variables. We know gender 1 is for female variable. It is a dummy variable for female respondents. So we rename gender 1 as female and we rename gender 2 as male. And now we know that these are our dummy variables. Now, how do we run regression with these dummy variables? Remember, we have generated generated these dummy variables using a manual way. So now execute this regression. So we regress the salary on, let's just say, 1 category. If there are 2 categories, then remember we just need to include 1 category. If there are 3 categories, then we would include 2 categories in our regression, and that is to avoid dummy trap. If you are not familiar with dummy trap, I have a whole tutorial on the theoretical aspect of dummy variable regression. In this video, we are particularly going to talk about Strata and some interpretation of those results. So because we have 2 categories, I'm just going to include 1 category. So it would be always number of categories minus 1. So we have our regression, and what it says is that it is significant. And what it says is that, so we have two values. One is the constant, and then we have a value for our category, which is male in this case. So this 179 means that male earns $179 more than female, right? And this constant is basically the salary for the omitted group. So this gives us the expected salary for the omitted group. So what this 965 would mean is that we expect that the omitted category, which is the female, would earn on average $965. But male would earn $179 more than female, and that is 965 plus 179. So that is how the interpretation would work. So it doesn't matter whether you include male or female or one category or another category into regression. It would just adjust the values accordingly, but the interpretation would remain the same. So in this case, let's include female instead of male. You would see that we get minus 179. So the values are exactly the same, right? Not exactly the same, but for at least the slope coefficient. And the interpretation, the values are different. I mean, there we had a positive value and now we had a negative value, but the interpretation remains the same. So here we interpreted it as male would earn $179 more than female. But here what we are saying is that female would earn $179 less than male. So the interpretation remains the same. The conclusion remains the same. With regard to constant, you would see that here we interpreted it as the mean salary of the omitted category. So female would earn 965, but here we can see that it is 1144 because that is the salary of the omitted category, which is male in this case. The omitted category in the second regression is male. So this is the expected salary of male, and if we deduct 179 from this value, we exactly get 965. So the interpretation would be in this case that female earns $179 less than male. Now that was somewhat a difficult way of working through it. There are certain shortcuts, and those shortcuts are not just shortcuts, they are more strata way of doing things, and they would help us in drawing graphs, in making the graph. So I would recommend not using the manual way. So let's drop these dummy variables that we have just created, and let's move on to this simple way. Now what happens is, first let me run the regression, and let me just show you what would happen if we run the regression, what error would we get, and how do we tackle with that error. So if I regress salary on gender, right, what it would say is that we do not have any observation. But if we look at our data, we do have a lot of observations. Now the issue is that we need to add I dot with this categorical variable, but still you would get an error. But that error is more, explicit. And what it says is that gender is a string variable, and string variables cannot be included in regression. So what does that mean? It means that this gender, you can see that it is highlighted red. This gender is a string variable, and string means it is a character, alphabetical variable. And for a categorical variable to be included in regression in Stata, we would have to convert it into a coded variable. So we'd have to code them. Now we can code a variable using encode command. So we write the encode command, then the name of the variable that we want to encode, then generate, and the name of the new variable that would be generated. So let's look at this and see what happens is that we get exactly the same values, but they are, colored blue. And that means that these female is not a character in the status memory. It is value labels. So if we click on female, you wouldn't see female over here. You would just see 1 because that is the code given to female. And if you look at male, you would see 2 because that is the code given to male. But if it was a string variable, you would see that specific string in this address bar. So okay, so the first step to use a categorical variable in regression is that we encode it. We are done with that, and now we can use a regression analysis. We write the regression command, the dependent variable, and the categorical variable. But see how we didn't include the gender variable, rather we included gender underscore e, which is the new variable that we generated, which is the encoded variable. So now we can use this I dot, and I dot is used with the categorical variable. So if I run the regression, and now you would see that we get our results, we get the variable name, and then we get the category label over here. And the interpretation remains the same. So male earns $179 more than female. There was one category that was omitted. And if you wanted to see which category was omitted, like I do not remember. Now in this case, we just have 2 categories, but if we had multiple categories, so it would be difficult to remember which categories we had and which category is omitted. So the easier way to look into which category was omitted is to use this all base levels option in Stata. Within this regression command, the regression command is exactly the same, but I have added this all base level option. Now what it would do is it would tell me that this female is the base category and it is omitted, right? So it is not included in the regression because we cannot include all the categories. One more thing is that we are familiar with using zeros and 1 in a dummy variable, but that is fine. If we have 1 and 2s, that is also fine. Like it wouldn't affect the regression analysis, at least in these 2 categories. Okay, now we need to generate a plot because, I mean, in this case, it is easy to know that male earns higher salary than females, but it would be more appropriate to see a graph, right? So for that, we first need to generate margins, and margin plots are a great way of, knowing how the results look like. Especially when we move to interactions and multiple levels and the interaction of continuous or categorical variables. So let me just execute the margin. So remember, margins command would only work when we have already run the regression. So the last command should be the regression command. So I'm using margins, and I'm just specifying the name of that categorical variable that I've used in my regression, for which we want margins. Now, what are margins? Margins are basically predicted values of the dependent variable for that specific category. Because we just have one categorical variable, it is the simplest statistic way. So let me just explain what this would mean. So we know that our predicted salary in this case would be equal to beta naught and beta 1 into whatever the value of that category is. So let's assume that it is 1 or 0. So we have 1 for male and 0 for female. We didn't have that, but let's assume that. That would make this explanation simpler. Okay, so we had this constant or beta naught of 965.6 plus this slope coefficient 179.3. So male had a value of 1. So if we multiply that, we get the expected salary of male, which would be 1145. And this is what we get. This is the expected salary of male from our regression model. What should be the expected salary of a female? It would be 965 plus again this beta naught plus beta 1. But because beta 1 have a 0 value in this case, so we get just 965, which is the expected salary for a female. Now we have margins or predicted values. We can plot these predicted values using a graph. So for that, we just use this margin plots. And margin plots, what this would do is it would take the previous margins command. So this should be the last command that you have executed in your Stata. So it would take last margins command, its results, and plot it on a graph. Now this is how the graphs look. Now how do we interpret this? We know that male earns higher than, we can simply look at this graph and we know that male earns higher than female, right? We can also see that there is a confidence interval over here, and our predicted values for female have more variation as compared to the predicted values for male. But obviously this graph doesn't look as good as we want it to be, because we do not want this line, because this line gives us an idea that it is a continuous variable. So what we can do is we can remove this line, and that would just leave these confidence intervals. We can do a lot of things with these margin plots. So in this video, I'm not going to be more focused on margin plots. We would have a video of its own related to margin plots, but I would give you some idea. Now, because we just have two categories, it would be nice to have a bar chart rather than scatter plot. Now this might be a great way of visualizing how the categorical variable would have an impact on our dependent variable. So we know that males earn higher than female. So that was for now. In our next video, we are going to talk about when we have more than two categories in our categorical variable, how would we perform regression, what are the different aspects of it, and how we generate margin plots. So thanks for watching this video. Stay tuned to the channel and do hit the bell icon.